Hello everyone. A very good evening or a very good afternoon to all of you. How are you all doing? Doing good, great. That's good. Good afternoon, everyone. Good afternoon. Good afternoon. So, how's the preparation going on? I hope this is going in the pink of health. Good. Very good. Very good. That's good. So, shall we carry on the chapter now? Okay. So, let's begin. So, today we will be doing, I hope we have done. So, please tell us this weekend syllabus from where to where. Okay. From nowhere to everywhere. There's a syllabus. No, it's not like that. So, it is basically from spectrum till whatever we will do today. Not today. I have to take one more class, I believe. So, according to the syllabus, we have to complete till Bohr's model. That means we have to complete radius, energy, velocity, and hydrogen spectrum. These things we have to complete. That actually means I have to take one extra class, maybe, because I will not be able to complete this much in this class. So we'll be looking for that. Shall we begin? But we should not be wasting time now. Coming over here. So let's begin. The hydrogen spectrum. The hydrogen spectrum, extremely important topic, very important topic. So see, first of all, let's think that what happens, that why we see a line, why we see light. Basically, see, the source of every light is that electron falls from a excited level to a lower level. Okay, so while doing so, if you remember that I told you that Maxwell told something. What did he tell? He told that if a charged particle, say for example electron over here, will move, will jump, will accelerate, and it will lose its kinetic energy in the form of electromagnetic radiation. This electromagnetic radiation is made up of quanta according to Max Planck, or photon according to Einstein. Is that clear? So a photon will be emitted, and for this photon we all know that energy of this photon will be h nu, or you can say hc upon lambda. So this wavelength I'm talking about is the wavelength of the photon, which will be emitted when an electron falls from higher energy level to a lower energy level. Is that clear? Clear completely? Okay. So that is basically how you will get a spectrum, a light, arrangement of frequencies or wavelength. Now what I'm saying is that suppose we have got, this is N1, this is N2, and N2 is more than N1. Okay. And the energy of this orbit is say E2, energy of this orbit is say E1. Now, when the electron is out here, if it jumps from higher to lower orbit, it will lose the energy and it will emit a photon, and whose energy will be like say delta E. Delta E will be what? It will be E2 minus E1, higher minus lower. So this delta E can be written as h nu, or equal to say hc upon lambda. Yes or no? This lambda, again I'm repeating, this lambda, this frequency, they all belong to this photon. Are you getting it? Yes or no? Everyone, respond. So gaye kya? Suna nahi hai. Are you getting it? So when a photon will be emitted, or you can say this is emitted, this will be called emission. This will be called emission spectrum. It will form an emission spectrum. When the photon is emitted, it will be going on the wall, the screen, and you will see an emission spectrum. Is that clear? And I'm assuming that this photon is say red in color. Suppose this is say red in color, and the energy, this difference of energy I'm assuming is, let's say, 10 electron volt. So this 10 electron volt is the energy of the red photon. Okay? Yes or no? Keep replying, yaar. Reply nahi kar rahe ho. So this 10 electron volt, and what I'm saying is that I'll just rub it off. So I'm taking one more case. So this difference, again, this is N1, this is say N2, this is say E1, this is say E2, and the energy of this one is E2, and this gap is same. That is how much? This gap E, delta E, is equal to 10 electron volt. Now your electron suppose is here. And you want to send it to the higher orbit. Now it will reach higher orbit when it absorbs energy. Yes or no? To jump in the air, you need to have some energy. Yes or no? So like when it will jump, this electron will jump up when it absorbs a photon. This energy gap is how much? 10 electron volt. This is also 10 electron volt. Now tell me, what do you think the color of this photon will be? This is a red color photon. This will be blue, what? Green or what? Come on, everyone. This will be very good, bacho. Very good. This will also be red in color, not blue. Nayak, why it will be blue? See, this energy gap is like say 10 electron volt. This is also 10. This is also 10. Each color is having a particular energy. Look over here. Look over here. If I say that we have got a spectrum, you forgot that something. This is say gamma ray. This is what? X-ray. This is UV ray. This is visible region. This is visible region. We are having infrared rays over here. We have got microwaves and we are having radio waves as well. Are you getting it? And I told you that as you move from here to here, what will happen? What will happen? Come on. Frequency decreases, lambda increases. And I have told you earlier that this E is equal to h nu is equal to hc upon lambda. So can I say that this E is proportional to frequency, is inversely proportional to lambda? Yes or no? Yes or no? That means if frequency increases, energy will also increase. Or if lambda decreases, energy will increase. So as I keep on moving over here, energy will also decrease. Will you all agree? This way, energy will decrease. That means the photon of gamma ray, okay, will have higher energy, but a photon of, say, radio wave will have lower energy. Will you all agree? Will you all agree? Every electromagnetic radiation will have a different energy. Though they all move with the same speed of light, but energies, frequencies, and wavelengths can all be different. Yes or no? Yes or no? Okay, now see, look at this visible part. If I say Vibgyor, and as I move from here to here, so tell me, who will have higher energy? Violet photon or red photon? Who will have higher energy? Yes, energy keeps on decreasing this side. Yes or no? Yes, so this violet photon will have higher energy. The red photon will have lower energy. Yes or no? That means every color has a different energy associated with it. Will you all agree? Good one. Good one. So that's what I was saying. That's what I was saying, that since the energy is same, that means the color should also be same. Different energy means different color. Yes or no? So suppose, if I send a photon of 20 electron volt, will it be red in color? Will it be red in color? No, it will not be red in color, because for red color over here, we are taking, for example, 10 electron volt. So it can be what? It can be blue, it can be violet, it can be anything above red. Is that clear? Yes or no? So good one. So since it is absorbing the red photon, it will lead us to what? Absorption spectrum. Are you getting it? Absorption spectrum. Now, what I'm saying is that when the electron is coming from here to here, it will throw red light. It will throw red light. Yes or no? But if the Vibgyor is coming, entire white light is coming, which is nothing but combination of all possible colors. So when the white light is coming, which photon, which color will be absorbed by the electron? Red color. That means when the entire light will pass through, which color you will not see on the wall? You will not see red color, because electron drank it. After drinking red color photon, it was energized and it went up. Yes or no? So over here, you will see red color, but over here, you will see every color except red. So can I say that both these spectrum are photographic negative? Photographic negative? Yes or no? It will be a photographic negative. Sure about it? Good one. So the colors which you will see over here will be the colors which you will not observe here. So can we say safely now, boys and girls, that suppose I'm talking about Vibgyor. So over here in emission, I am witnessing violet, green, and red in emission. So in absorption, which colors I will notice? Which colors I will notice? Come on. I will notice the remaining colors. I'll notice indigo. I'll notice blue, yellow, and orange. Yes or no? That's good. Yes. Very good. Very good, Bichu. Keep it up. You're doing so good. Keep it up. So that is an idea of how you find a spectrum out there. And I believe that you all understand that they will all be like what? A line spectrum if you're talking about hydrogen atom. Yes or no? Okay, so atoms gives you line spectrum. Line spectrum over here we are discussing are two types, absorption and emission. Emission spectrum will observe when the electron falls from higher to lower energy level, and absorption you will notice when it goes from lower to above. Okay, that part done. Okay, now let us see more about hydrogen atom. Na? So hydrogen atom, I'm telling you boys and girls, so this is all about the spectrum out here. Spectrum. Since you are in a dropper batch, I believe that you all know what I'm going to say, that I'm drawing. This is orbit number 1 for hydrogen, orbit number 2, orbit number 3, orbit number 4, orbit number 5, 6, 7, and so on. And this will be the orbit number infinity. Orbit number infinity, yes or no? So this is orbit number 1, 2, 3, 4, 5, 6, 7, 8, and so on, and orbit number infinity. Who will tell me what is the energy at orbit number infinity? Who will tell me? It is 0 electron volt. It is 0 electron volt. So when an electron is at infinite orbit, we call it the electron in the free state. Other states are called bounded state because they are bounded to nucleus of the atom. Sure about it? Chalo, okay. So the point is that, boys and girls, that when we are having different orbits, we have different orbits. So suppose electron is here, it can fall from anywhere to anywhere, and this process is quite random. No one, not even sometimes I think not even God knows that electron will jump from where to where. Okay, so like it can jump like this and this, or it can directly come over here, or it can come over here, then over here, maybe here, then coming there, maybe here, then, and this like this. Sure about it? So electron can take many jumps, I mean many jumps. All possible, yes or no? So like when we are not tackling certain organized thing, so wherever the electron is, suppose, what I'm saying is that it can jump, say, from here to orbit number 1 directly. It can jump to orbit number 1. If it is here, wherever it is, like, it should come to orbit number 1. Are you getting it? It should come to orbit number 1. So when it comes to orbit number, from wherever it is, directly, okay, so the lines, the photons you will get will be belonging to Lyman series. They will belong to Lyman series. Are you getting it? And Lyman series, we all know that these photons, they lie in what? UV region. They lie in UV region. Ultraviolet region. Very good, bache. Very good. Trishal, very good. Now see, so wherever you are, in case if the electron falls from wherever you are to orbit number 2 directly, wherever you are, should come where? To orbit number 2 directly. Are you getting it? So once that happens, you will get Balmer series. And this will lie in visible region. Yes or no? Come on. Similarly, wherever you are, if you come directly to orbit number 3, wherever you are, which series you will get? Come on, which series? It will be called Paschen series. Yes or no? And this will lie in what? Near infrared region. Very good. And suppose you come directly to orbit number 4, directly, wherever you are, you will get bracket series. Okay, and this will be lying in infrared region. Very good. And over here, say, if it comes directly to orbit number 5, you will get Fund series. So let me create some space for you people. And Fund series lies in far infrared region. It will lie in far infrared region. Very good. And last but not the least, I mean, which we have got in syllabus kind of thing, is that if you are anywhere and you are coming directly to orbit number 6, so this will be like what? Come on. Should be here. Na? Should be here. Come on. It will be called Humphrey series. And Humphrey series again lies in what? Far infrared region. Remember that, boys and girls, that Paschen series, bracket series, Fund series, or Humphrey series, they all collectively are called lying in infrared region. Yes or no? So broadly speaking, there are only 3 regions where a photon will lie in hydrogen atom. First one is Lyman series, which will lie where? In ultraviolet region. Then second one is what? Balmer's region, which will lie in what? Visible region. And remaining all will be lying in the infrared region. Getting it? Until unless in the question they are asking that how many lines will be formed in the far infrared region or say near infrared region. Don't think about that. Just think about infrared region collectively. Sure about it? Okay. So let's move now. Now coming back over here. So let's move and just give me one example. So these are the orbits I'm drawing roughly, and we're coming directly to orbit number 1. You will call them Lyman series. Okay. Now remember that there's orbit number 1, 2, 3, 4, 5, 6, and so on. This first line will be formed if the electron jumps from second to first, just above, or H alpha. Alpha is the first Greek letter, so H means hydrogen atom. So first line of hydrogen atom spectrum. Okay. Sometimes they use different terminologies, and if you do not know that, you might land in some problem. Getting it? Similarly, the second line, boys and girls, this will be called or H beta line. H beta line. Yes or no? Good one. Very good. And third line will be called H gamma line. So sometimes, you have to very well versed with the terminology. Sometimes they ask you terminology, and if you are not aware, you might lose it. Okay. And we don't want to lose any marks in the NEET examination. And like last but not least, this is the last line. Last line means coming from infinity. Okay. I'm assuming that is coming from infinity. This will be called last line, or you can say limiting line, Are you getting it? Will be called limiting line. This happens everywhere. Even if we talk about, say, you're coming in the Balmer series. Are you getting it? Just wait. Sorry for the interruption, Michu. Okay, so I hope this is done, correct? Okay, so this will occur. Even if you're talking about Balmer series. First line is always alpha line, beta line, and gamma line. They won't ask you beyond it. And last line will be always called limiting line. Yes or no? Pardon me for that. Am I audible? Now? Audible to all of you? Audible. Okay, great. So my question is that if I'm looking for, say, first or say alpha line in Balmer series, come on, tell me the electron should jump from where to where? 3 to 2. And similarly, the beta line in Balmer series, it should jump from 4 to 2. Very good. And gamma line will be from 5 to 2. And last line or limiting line will be from infinity to 2. Yes or no? Similarly, if I talk about, say, Paschen series. In Paschen series, the first line or alpha line will be from, 4 to 3, just above. 4 to 3. Bharadwaj, 4 to 3. Getting it? Beta line will be from 5 to 3. Jumping on 3 is compulsory in bracket series, sorry, Paschen series. Yes or no? And this will be gamma line from 6 to 3. Last line will be like say from infinity to 3. Clear? Okay. So this part is done now. Okay, this part is over. Very, very important part. So what I'm saying is that if I talk about Lyman series, है ना? So this is say N1 and this is say N2, higher orbit, and N2 is always higher than N1. So N1 will be what? 1 for Lyman series, and N2 will be what? Any orbit higher than that. That is 2, 3, 4, and so on till infinity. Agree? Similarly, for Balmer series jumping on directly on orbit number 2 is compulsory. From where? Anywhere above it. So 3, 4, 5, so on till infinity. Similarly, Paschen orbit number 3 is compulsory. You have to jump directly to orbit number 3. From where? Any orbit above 3. That means 4, 5, 6, and so on till infinity. Are you getting that? Similarly, for bracket series, come on. 4 from 5, 6, 7, and so on till infinity. Are you all getting that? Are you all getting that? Okay. So when electron is jumping from a higher orbit, this N1, this is say N2, N2 is higher than N1, and this is say E2, this is say E1. Are you getting it? The energy of orbit number 1, this one is say E1, for this one it is E2. So a photon will be emitted, and the energy will be what? Delta E, which will be equal to what? E2 minus E1. E2 minus E1. So can I say that energy of this photon, delta E, which is equal to E2 minus E1, is equal to H nu, is equal to Hc upon lambda? Yes or no? Yes or no? Very good. Very good. So can I say that this delta E is proportional to frequency, is proportional to 1 upon lambda, which actually means that delta E will be higher if frequency is higher. That means lambda is lower. Or I can say delta E will be lower if frequency is lower, or you can say lambda is higher. Yes or no? You will be solving many questions on that in short while. Many questions on that. Okay? Okay? Now see this thing. What I'm saying, that whenever electron, this is again N1, this is again N2, and this energy gap is called delta E, and a photon is coming, electron is coming down, and the photon will be emitted. Sure about it? So it will have some lambda, it will have some wavelength. So this wavelength is given by the formula 1 upon lambda equal to R into Z square 1 upon N1 square minus 1 upon N2 square, where N1 is less than N2. N1 is less than N2. Getting it? So over here, Z is the atomic number of that species we are talking about, and R is called the Rydberg's constant. R is called the Rydberg's constant. And for hydrogen atom, the value of R is equal to 1.09 into 10 to power of 5 per centimeter. Boys and girls, if you remember, I told you this 1 upon lambda is also called what? Nu bar, wave number. Remember that? So if they are asking wave number, this is it you are going to calculate. Is that clear? Okay. So here we go. Or you can write down, or you can say it will be 1.09 into 10 to power of 7 per meter. 7 per meter. Even more important, boys and girls, is that this value of 1 upon R is equal to 912 angstrom. Sometimes we will be using this information also. Very good, Trishal. Very good, Priyanka. Very good, Shamt. Very good, everyone. So can I move forward now? This is done? Okay, good, very good. So we'll be using this stuff in a short while. But now, before I move to this lambda part kind of thing, so when I told you that when an electron is jumping or is having the choice to jump from higher to lower orbit, it can jump in various ways. Yes or no? It can jump directly also. Yes or no? Many ways it can jump, over here and here as well. Yes or no? So how many lines or how many photons will be emitted? I mean, different photons will be emitted. For that, we have got one more formula, that total lines formed when an electron jumps from N2 to N1. If a jump is from n2 to n1, in how many ways it can jump, है ना? So total lines will be equal to n2 minus n1 into n2 minus n1 plus 1 divided by 2. You need not worry about derivations. These are all permutation combination. In a NEET examination, they are not going to ask you, please derive it. Until unless you derive, we are not going to give you marks. So forget about that stuff. We know the formula, and the point will be you got to calculate or find the answer of the question. So like one more thing over here. So if electron falls from orbit number n to orbit number 1, how many total lines will be formed? Total lines formed will be how many? Instead of n1, put 1. Put 1. So if it is 1, this will cancel up. This will become n into n minus 1 upon 2. You can use this formula also, but using this will give you like more confidence kind of thing. This is more like good looking, short and crisp formula. Okay? Yes or no? Shall I? Shall I? Okay, so let's do some questions now. Let's do some questions. Very, very important. So I'm saying that electron falls from orbit number 10 to orbit number, say, 1. Find total number of lines formed. These total number of lines will include all of them. Lyman lines, Balmer lines, all those lines. Okay? So if the electron is falling from 10 to 1, find the total number of lines which can form, which are possible lines. So Priyanka is the first one to give the right answer. Then Trishal comes. Then comes someone 000. Jyotika. Okay. Bharadwaj. Good. Very good. Very good. So total number of lines formed will be given by, this is coming to orbit number 1 na. So can I say this will be n into n minus 1 upon 2 will be 10 into 9 by 2 will be equal to 45. Yes or no? Yes or no? So total number of lines are 45. Now, even a better question, even a more important question is that, tell me one thing. If I ask you, these are total number of lines, which will include what? Lyman, Balmer, Paschen, Brackett, Fund, Humphrey, all of them. Sure. So what I'm saying is that in the same question, find number of Lyman lines. Find number of Lyman lines. Who will tell me how many Lyman lines will be formed? How many Lyman lines will be formed? Come on. Come on. Bharadwaj says 10. Trishal says 9. Anyone else? Be quick, guys. Be quick. We don't have time. We're running short of time. Priyanka says 9. Vasavi says 45. Okay, see that. It is always given by n minus 1. N minus 1, which will be in this case 10 minus 1 equal to 9. So total number of Lyman lines will be 9. I can give you an example. Say for example, this is it. Na? So 1, 2, 3, 4, 5. Suppose it's n is equal to 5. Electron is jumping from here. So how many Lyman lines are possible? 1, 2, 3, and 4. How many of them? 1, 2, 3, 4, 4. So how did I got 4? 5 minus 1. So total number of Lyman lines will be how much? N minus 1. Achha, how many Balmer lines will be formed? This is 5. 1, 2, and 3. How you got it? N minus 2. 5 minus 2. Jyotika, what is it? Okay? Okay. So let's come back. So number of Balmer lines. Number of Balmer lines will be equal to n minus 2 equal to 10 minus 2 equal to 8. Or you can see that the number of Balmer lines are always 1 less than Lyman. 1 less than Lyman, okay? So number of Paschen lines, who will tell me, will be equal to how much? 10 minus 3 will be equal to 7. Yes or no? And again, 6, 5, 4, 3, 2, 1. Yes or no? This will be bracket. These will be number of bracket lines. This will be number of Fund lines. This will be number of Humphrey lines. Are you getting it? And so on. 6, 5, 4, 3, 2, and 1. And end result will be, if you add them all, what are you going to get? You're going to get 45. 9 plus 8 plus 7, 6, 5, 4, 3, 2, 1. You will get 45. This 45 is nothing but these many lines. Total number of lines. These total number of lines are nothing but summation of all the possible lines from Lyman to Balmer to Paschen to Brackett and all of them. Is that clear to all of you? Yes or no? Understood, everyone? Good one. Great. Very good. Extremely good. So come over here. Okay. Now, I'm saying that electron falls. Electron falls from, let's say, 8 to 3. 8 to orbit number 3. In how many ways it can fall? Or you can say, in other words, how many lines will be formed? Come on. Come on. Okay. So 8 to 3. So total number of lines formed is what? I told you, n2 minus n1, n2 minus n1 plus 1 upon 2. This will be 8 minus 3, 5 into 6 upon 2 will be equal to 15. So total number of lines formed are 15. Yes or no? Now who will tell me how many number of Lymans lines are formed? Number of Lyman lines will be equal to how many? Come on, everyone, be quick, be quick. Arey, how come 14? This is total number of lines. This is not n. The Lyman lines are n minus 1. And n is what? N is 8. N is 8. Yes or no? It cannot be 14. Are you getting or not? But the answer is 0. Answer is 0. The reason, who will tell me the reason? The electron is not coming to orbit number 1 at all. It is stopped at orbit number 3. Not coming to 1. Very good. So number of Lyman lines will be 0. So we have to have an open mind. है ना? दिमाग बंद थोड़ी करना है क्या आपने को? Are you getting it? Once you become a doctor and you're trying to operate a person who is having a kidney problem and you are operating the heart. ऐसे थोड़ी करने का है. So number of Balmer lines will be equal to again 0. The reason the electron is not coming to orbit number 2, and now coming to number of Paschen lines. Number of Paschen lines, yes, will be what? 8 minus 3, n minus 3, because coming to orbit number 3 is compulsory in Paschen series. Yes or no? So this will be equal to 5. And number of bracket lines will be equal to, keep on subtracting 1, 4, then 3, then 2, then 1. This will be what? This will be Fund. Yes or no? This will be Humphrey, and total becomes 15. So these are total number of lines. Yes or no? I was a bit surprised to see you guys saying 14 as the answer. 14 cannot be the answer. You are not going to subtract 1 for Lyman series out of total number of lines. That is n minus 1. What is n? N is the orbit number. N is the orbit number. Yes or no? So let me just do a rough exercise with people. Suppose the electron falls from orbit number 18 to orbit number 1. Are you getting it? So total number of lines will be different thing. Are you getting it? But Lyman lines will be 17. Are we getting it? Everyone? Balmer 16, 15, and like this. So when you will add it, you will get total number of lines. Right? Let's move from here. Okay. So once we have done that stuff, let's do one more question. So question is that electron jumps from n to 1, and total lines formed are equal to, say, 10. They're saying find n. If total lines are 10, find n. From where the electron is falling. You are not understanding, boys and girls. See that total lines, when it forms from n to 1, is n into n minus 1 upon 2. This is given as 10. I'm not saying only Lyman lines. I'm saying total number of lines. Who said? I'm saying about Kiran. I didn't said that these are Lyman lines. Electron is jumping from n to 1 in how total number of lines which can be formed. Are you getting it, everyone? So like this will be n into n minus 1 equal to 20. Is that clear? Is that clear? So you can make a quadratic equation, or you can do one thing. The difference between these two numbers is 1. These are two factors whose difference is 1. Your job is basically to find two numbers whose difference is 1, but the product is 20. I believe this will be 5 into 4. Yes or no? 5 into 4 will give you 20, and the bigger number will be your answer always. Bigger number will be your answer because bigger number is n, smaller is n minus 1. Yes or no? So can we do certain other questions which are like, say, kind of practice? So if I said total lines are formed as say 21. Total lines formed are 21. Find the orbit number. They are falling from n to 1. Electrons are falling from n to 1. What is the value of n if total lines formed are 21? So n into n minus 1 upon 2 is equal to 21. So n into n minus 1 will be equal to 42. Yes or no? So 7 into 6 will be equal to 42. Your bigger number will be your answer, 7. Yes or no, beta? Are you getting that? All of you? Is that clear? Okay, now see that. So question is that n electrons are falling from n to 1. From n to 1, I'm saying if total lines in UV region is equal to 5. UV region is equal to 5. Find total lines in infrared region. Find total lines in infrared region. Come on. Electrons jumping from n to 1. If total lines in UV region is 5, find total number of lines in IR region. Find total number of lines in IR region. Come on. Can I drink water till then? To the question, I'll have water. Okay, let me do it. So one thing is for sure, UV region actually means Lyman lines. Actually means Lyman lines, है ना? And Lyman lines is equal to what? N minus 1 equal to 5. So n minus 1 is 5, so n will be equal to 6. That means electrons are falling from orbit number 6. Yes or no? Yes or no? So if I talk about Balmer line will be how many? It will be 5. No, it will be 4. It will be 4, just one less than the Lyman lines. Is that clear? It will be 4. Come on, but these are visible. These are visible. And I don't want visible lines. So that is not going to be my answer. Okay? But if I talk about pastel lines, how many? 3. Come on, bracket. Bracket lines will be equal to 2. And number of fund lines. Fund lines will be equal to 1. Now tell me one thing. I believe I told you that these all three, they all belong to infrared region. Yes or no? They all belong to infrared region. So total number of lines will be 6. Pastel lines are not the lines, only lines which lie in infrared region. Okay? So you got to be a bit careful. You said, Ahai said, but what is his name? You can put your proper name. I can pronounce that name. So this is the Hai gave this answer 6. But I believe Gautam gave the answer first. He was the first one to answer that question properly. Okay, so I hope this part is done, number of lines kind of thing. So shall we move ahead? Okay, chalo, come. Now I give you formula that 1 upon lambda is equal to r into z square, and 1 upon n1 square minus 1 upon n2 square, where n1 is less than n2. And this lambda is the wavelength of the photon which is given when an electronic transition is occurring. Okay? Okay. Now I also told you that delta E will be maximum if frequency will be maximum, and that means lambda will be minimum. Will you all agree? Will you all agree with me? All of you? So tell me one thing, delta E will be maximum when? When do you think delta E will be maximum? when the electron, suppose you can take Lyman series, so we have got different orbits, and this is orbit number infinity. So what do you think? Electron should jump from where? This one, this one, this one, this one, or this one, from infinity to orbit number 1. If you want the greatest difference between energy, delta E should be highest. That means this is lowest energy level, this is the highest energy level. So I mean the difference should be between highest and the lowest one. Agree or not? That actually means that N2 should be infinity. Will you all agree? N2 should be infinity and N1 should be equal to 1 for whom? Lyman series, obviously, and N1 should be equal to 2 for whom? Balmer series, and so on, because coming to orbit number 2 is compulsory in Balmer series, and similarly N1 should be equal to 3 in Paschen series. Yes or no? So remember this thing, whenever they're looking for lambda minimum or frequency maximum, please choose N2 equal to infinity. Sure? It should have the biggest difference of energy, which is only possible if N2 is infinity. Sure? Okay, come on. Now, I know that delta E will be minimum only if frequency is minimum, or you can say lambda is maximum. Is that clear? Is that clear? And delta E is minimum when the electron jumps from just above orbit in any of the series, just above, yes. That means alpha line, very good beta Priyanka. The minimum energy will be for alpha line in any given series, the first line, and to have first line we need what? N2 minus N1 should be equal to 1. Will you all agree? The difference should be of only 1. Is that clear? Okay, great. So N2 minus N1 should be equal to 1. Now, loaded with this stuff, we got to solve some problems now. Okay, so what I'm saying, question is that find lambda max and lambda minimum in Lyman series of hydrogen atom. Come on, you have to find the value. Try it, give it a try. Till then, let me have some water everywhere. Okay, I'll help you. So we know the one thing, for lambda maximum, I know that delta E should be minimum, and for delta E to be minimum, I know that for Lyman series, electron should jump from 2 to 1, the first line, the alpha line. Yes or no? Now I know that 1 upon lambda will be equal to R into Z square, 1 upon 1 square minus 1 upon 2 square. So Z is 1 for hydrogen atom. Will you agree? Will you all agree or not? So 1 upon lambda will be equal to R into 1. This will be 1 upon 1 minus 1 upon 4. And 1 upon lambda again can be written as R. This will be getting 3 by 4. Yes or no? Or I can say lambda will be 4 by 3R. Yes or no? 4 by 3R. Or R will go down. Okay? Very good. So Priyanka has solved the second question as well. So lambda min means delta E has to be maximum. If delta is maximum, that means N2 should be infinity and N1 should be what? 1. Yes or no? So in that case, 1 upon lambda will be R into 1 for hydrogen atom. Okay? And 1 upon 1 minus 1 upon infinity. That actually means 1 upon lambda is equal to R. So lambda will be equal to 1 by R. Will you all agree with that stuff? This is what? Lambda max. This is lambda max and this is lambda minimum. You can solve it further, Kiran, by putting the value of R as if they ask it. Generally they don't ask it. They ask you the answer in format of R. Okay? So now you are going to solve the same question for Balmer series for the sake of practice. Come on, do it now. You got 2 minutes to solve it. No, not 2 minutes, 1 minute to solve it. Get done. Everyone. Come on. Okay, let's see that. Let's see that now. Let's see that. I'm talking about lambda max and lambda min in Balmer series. Okay, lambda max and lambda min in Balmer series of hydrogen atom. Okay, so again, as usual, you know that lambda max means delta E should be what? Minimum. Delta E should be minimum only when for Balmer series electron should jump from 3 to 2, the first line, the alpha line. Yes or no? Very good. So if that's the case, 1 upon lambda will be equal to R into 1, and this will be like say 1 upon 2 square minus 1 upon 3 square. N1 is always smaller. So 1 upon lambda will be equal to R. This will be like say 1 by 4 minus 1 upon 9. Solve it. 1 upon lambda will be R. This will become, I believe, 9 minus 4. 9 minus 4 upon 36 if you take the LCM. So this 1 upon lambda, I believe, will be 5R upon 36. And from here, if you allow me, can I say that lambda will be 36 upon 5R? 36 upon 5R. Yes or no? Getting or not? Good, great, very good. And over here, if you allow me now, can I say that lambda min means delta E has to be maximum. It has to be maximum. Delta E will be maximum only when we are jumping from orbit number infinity to orbit number 2 for Balmer series. Yes or no? Now, 1 upon lambda will be equal to R into 1 upon 1, 4 minus 1 upon infinity. Yes or no? Which actually means 1 upon lambda will be equal to R by 4, which means lambda will be 4 by R. Yes or no, boys and girls? Come on. 4 by R. Good, good, good. Now, just one question to all of you. Just one question to all of you. That are you satisfied with your performance? I mean, in the past 1 month or what? Or you want, like, say, more of a performance kind of thing? You want more improvement? So definitely, I mean, I can understand that we all need improvement, because we have just given the NEET examination last year and we were not able to qualify this, or we were not able to score the way we wanted to do it. And that's why we have taken one more drop, and we are willing to put everything we have got to make sure that we get the results we want. Are you getting it? Yes or no? Yes, everyone? Yes, good. Nayak, Wasabi? Got. Priyanka. Like, see, understand one thing. The very important part is that sometimes you feel motivated, and sometimes you feel motivated, but sometimes you feel not that much motivated. I'm not saying that you are feeling demotivated, but sometimes we are not feeling motivated. Not every time we can feel motivated, when the life pulls, because of the gravity kind of thing, the problems of life and X, Y, Z occurring in our life, which are beyond our control. So sometimes we get frustrated, sometimes we are like in anger kind of thing, and we do not know how to resolve the problems. Is that clear? So when you are not feeling motivated, students, you should develop a discipline, because discipline begins where motivation ends. So if something is not going right, since you have developed that discipline, which will pull you through all this darkness. And as they say, Gudiya and Bacho, that whenever you are into a hell, don't stop. Keep moving, because we don't want to live in hell. If you find yourself living in hell, keep moving. Even if you're broke, you are feeling very low, you are feeling sad, you are in the darkness kind of thing, which has got no tunnel out there. Keep moving, just keep moving. Don't stop out there. Okay? Stopping means death. And you cannot be dead. You should be dead only once you have lived the life. So live the life, and to live the life, you need to have motivation, obviously. And once it is like, say, dwindling, you should have a discipline to counterattack of the life problems. Is that clear? Yes, good. Very good, Surya. That's good. That's what I'm looking for, that you are improving slowly and slowly. Are you getting it? Now, one more thing. How many of you people feel that, sir, that I'm working very hard, but I'm not getting the marks which I deserve, basically? I'll tell you why you're not getting that. There are many of them. Yes, obviously, there are many of them. So, like, we try to fool ourselves. How we try to fool ourselves, bacho? That we will open the book, and by opening the book, if your mind is in, say, past or future, you're thinking about the family, the friends, or some event which occurred today or maybe yesterday. You are hung out there, you are just hooked on to that. But you are looking into the book, and your mind makes you believe, since you are picking up the book, and it gives you a feeling that you're studying. So if your father calls you up, boy, you are studying or not? Father, I'm working very hard because I am opening the book. And when father sees you, he sees that you are actually studying. But the fact is that you are physically into the book, but not mentally. Mentally, 60% or 70% of brain is somewhere else, because of some incident which occurred, which you liked or not, but you are stuck somewhere else. Are you getting it? Like, one more thing I'll like tell you. It sometimes happen that what you desperately want, you will be looking for, and whatever you will be looking for, you will see that only. You will see that only. Yes or no? Yes or no? So suppose it's, if your priority is something else, something else. So people, when I talk to the who are in the campus out there, so if someone has come over here to make friends, he will find friends, make a good company out there, hang around for 1 year maximum, and after that it's the end of the journey. The people who are here to sleep, they will find some place to sleep. Are you getting? The people who are here to get worried, they will find something to get worried. Whatever you want, you will get it. Life is so kind. Whatever you will, whatever you want, you will get it. Everyone gets it. If you are here to get the marks, you are getting marks. You will have some difficulty, but you know how to overcome that. Someone who wants to sleep will sleep at any point of time. He or she will sit at the back bench, will sleep. Yes or no? If you're not here to focus on the board, you will not focus on the board. With your open eyes also. You will learn how to sleep with the open eyes. You will devise like new methods how to appear awake while you are asleep. Yes or no? Will you all agree? No, it's not about destiny. Destiny, there are certain things which are beyond your control, but there are many things which are under your control. I cannot control what is going to happen to me, but I can definitely control how I will react. So something bad happens to me, I have got two ways. Suppose someone is abusing me, I've got two ways. I should start abusing him in return, which will make no difference between me and him. Second is that I don't react. Not everyone needs your attention. Not everyone, not every dog who is barking at you, you should not bark at him at all. Avoid. Get busy, keep busy yourself, become unavailable, become unreachable till you become the king. You see, have you seen, I mean, that lion is, I mean, responding to the dogs who are barking out? Kaisi baatein kar rahe ho yaar? No chance, no chance. So whatever you are looking for, you will see that, you will get that also. I'll tell you one thing. So, I mean, if I'm talking to boys, I'm talking to boys. If you are going through a busy market kind of thing, and it's happening market, so you're riding a bike kind of thing. So what you will see first, boys, what you will focus in a busy market, happening market? You will focus on way. Oh my God, he will focus on way. Gautam. Vivo will focus on road. Wow, great. No. I'll tell you, at this stage, you will focus. Yes, correct, Medico. I mean, he's very good. I mean, that you will focus on girls. Yes or no? You will definitely focus on some beautiful girls out there, and there are many of them. Yes or no? You will not focus on the way. You will not focus on the road kind of thing. Don't tell me. Yes or no? No chance. I know that stuff. And also see that in that busy market, there are some 100 aunties also passing by, and 3 beautiful girls are passing by as well. So you will be focusing on 3 girls, but not on the aunties. If I ask you, I mean, how many aunties did you notice, and like what they looked like, you'll say, sir, pagal ho gaya kya? Ye kya pooch rahe ho? I mean, who will focus on aunties kind of thing? I'll be focusing on those things, and you will be able to describe everything about them. Aunties were there, uncles were there, shopkeepers were there, beggars were there, but you focused only on that. Whatever you look for, you will focus on that, and you will neglect other things. You will neglect that. Similarly, so when I'm talking to you people, in your room, there is a fan running, there is a AC running. I mean, some other things are coming. I mean, all kind of sounds are coming. Your room is filled of all kind of radio waves, all kind of sound waves, but you are not focusing there. Yes or no? Are you able to listen to that? You're not right now, because you are completely absorbed, focused on me. So once you are absorbed, you want to listen to me, you want to listen to me, you will listen to me only. But if you are interested in the voice of the fan and the voice of AC, you will focus there. Whatever you will focus, you will get it, boys and girls. So please focus on studies, and good studies, good focus. You will get it, bacho. You will get it. There is no chance in this. There is no destiny. Please, I mean, it's your choice basically. You can choose to listen to other things. You can choose to listen to me. It's your choice. No one is forcing you. No one will ever force you. No one will force you to sleep. No one will force you to focus over here. It's up to you, boys. It's a jungle world out there. It's a jungle rule. No one is going to help you out. You are the only help. You are the only help coming yourself. So keep studying, keep focusing, bacho, and please don't distract. Don't distract. Why I'm saying that you are more than sufficient, bacho? Because you are more than sufficient. If you don't have friends, you don't have technology, you don't have this and that stuff, you don't need that. You are perfect. You are more than required. You are more than sufficient. Begin from wherever you are. Are you getting it? Are you getting it? Keep on moving slow, steady. Keep roaring. Keep on hunting your goal. Chase it. Hustle. But don't cry. Don't weep. Okay? Just find it. Just find it. This way, that way. Getting it? Sure? You will get whatever you want to get, but prepare a good system for that. If you want AIMS college, you will get it. For that, you need to have very strong system, that many deviations will be coming. Someone will recommend movies. Someone will recommend we can go for outing kind of thing, and we can have this and that kind of enjoyment. Avoid it. Become unavailable, unreachable till you hunt your target. Is that clear? Once you hunt your target, whatever target is, you will get it. Target is logged and logged. It's a fire and forget policy. I mean, don't lower your targets. Don't lower your, ambitions. Upgrade your skills, bacho. Upgrade skills. Okay? Thank you. Thank you so much. So can you come back again here? Can we come back again? Yeah. Thank you. Thank you. Thank you very much. Chalo. Okay. Now say if I ask you one question, who will find me the ratio? Who will find the ratio of lambda max of Lyman series and lambda max of Balmer series? Lambda max of Balmer series. Come on. All these you have done right now. All these you have calculated right now. Lambda max of Lyman. Who will tell me the value of lambda max Lyman? Come on. Lambda max Lyman. You have just done it right now. Lambda max Lyman. 4 by 3R. And what is the value of lambda max Balmer? Lambda max Balmer? 36 5R. Yes or no? So R and R cancels. 4 9 9 3 27 will be 5 by 27. So these kind of questions, bacho, you will be facing around. Are you getting it? Are you getting it? And you can handle them very carefully. Sure? Okay. So, okay, let's move forward now. Let's move forward and let's do some, like, say, more question. And, okay, like, there are certain questions which we need to handle, but for that, we need to have some data as well right now. Bohr's model I'll do in the next class, but before that, I can give you some values which you can learn. Sure about it? So let's see that. Let's see that. If I'm talking about hydrogen atom, I'm talking about hydrogen atom. There are certain values of energy which you should be aware, which you should be aware, which will make you very, very strong, very, very strong. Okay, boys. This is say 1, 2, 3, 4, 5, and so on. This is orbit number infinity, and the energy of the orbit number infinity is 0 electron volt. This is minus 13.6 electron volt. This is minus of 3.4 electron volt, minus of 1.51 electron volt, minus of 0.85 electron volt, minus of 0.54 electron volt. Yes or no? This everyone has to learn. And apart from that, the difference between orbit number 2 and orbit number 1 in terms of energy is 10.2 electron volt in hydrogen atom. Please, this difference between 3 and 2 is 1.89 electron volt. This difference is 0.66 electron volt, and this is 0.33 electron volt. Are you getting that? Are you? So just learn these values. These are extremely important, very, very important. Once you learn that, since others are not learning that, so you are doing some extra. So extra every day will make you extraordinary in the long run. So keep doing that. What others are not doing, just do that. Otherwise, you will be the part of the crowd, and crowd doesn't go to Ames College. Sure? So let's see that. So E2 minus E1 is 10.2 electron volt. Come on. E3 minus E1 is how much? Sorry, E3 minus E2 is how much? 1.89 electron volt. And E4 minus E3 is how much? 0.66 electron volt. E5 minus E4 is how much? 0.31 electron volt. Are you getting it? Can you see that? The energy difference between two consecutive levels or orbits is decreasing as we move away from the nucleus. Yes or no? You have to learn certain more values which are equally important. E3 minus E1 is actually 12.09 electron volt. E4 minus E1 is actually 12.75 electron volt. And last but not the least, E5 minus E1 is actually 13.06 electron volt. Just learn these values and you will not regret what I am saying. You will not regret it, bache. Trust me. Just learn these. So I'm going to give you one question. I'm going to give you one question over here, and understand that very, very carefully, bacho. Very carefully. So I'm saying you have to find a ratio. Question says find a ratio of frequency maximum, frequency, or you can say because the frequency not maximum, frequency minimum, frequency minimum of Lyman upon frequency maximum, minimum again for Balmer. Both are minimum. Can you find it? Can you find it? I know one thing, that delta E is equal to what? H nu. That means delta E is proportional to frequency. So the ratio of frequency is also the ratio of energy also. Yes or no? Delta E minimum upon delta E minimum. This is for Lyman series. This is for Balmer series. Will you all agree? Will you all agree with me or not? Come on. So what is delta E minimum for Lyman? Delta E minimum for Lyman is what? 10.2. 10.2. Yes or no? And delta E minimum for Balmer is what? E3 minus E2, just above? Just above the 2. Yes or no? There will be 1.89. So when you solve it, you will approximately get 5. You will approximately get 5. There is a questionnaire module who says that the answer is actually 5.4. Other options are very far apart, like say 0.25, 1.25, 5.4 and 10. Definitely, this thing is more than 1. So this cannot be the answer. Yes or no? Also, I know approximately this is say 10 and this is say 2. Hello, approximately. So this answer must be near what? 5. This cannot be the answer. This cannot be. So there is no need to solve a question completely in physical chemistry in general. 99% time you need not solve it completely. Do it approximately and keep moving. Keep moving. Yes or no? Yes or no? Okay? Okay. So that is it. So these kind of questions are there in your module and you need to finish them off. Okay? Now coming to the Bohr's model. Just a quick glance to Bohr's model. Bohr's model, and I'm giving you the pictographic memory for that. There is no need to write a statement, it's everywhere. He said that, first of all, write down, his model was based on classical theory. Based on classical theory. Classical theory means that old theory, electromagnetic wave theory, and what? Come on. And quantum theory. Quantum theory. And this thing is also his biggest drawback. This is his biggest drawback also. Biggest drawback. So now, why this is the biggest drawback? Because classical theory said that energy is moving continuously, and quantum theory says that it moves discretely. So he is trying to combine continuous and discontinuous. Discrete, yes or no? That was his biggest drawback. His purpose was to solve the questions related to hydrogen spectrum. Okay, and he also said that electron has particle nature. Has particle nature. And his model was applicable. His model was applicable to one electron species. One electron species means the species which have got only one electron only. Like what? Like what? Like say hydrogen, helium plus. Helium has got 2 electrons. Remove, no, not He plus 2 beta. It is He plus 1. Helium has got 2 electrons. Remove 1. 1 will be remaining now. 2 electrons are there. Remove 1. Only 1 is remaining now. Similarly, lithium has got 3 electrons. Remove 2. Remove 2. Only 1 electron will be left. Okay. Beryllium 3 plus and so on to any species which is Na plus 10 also. Na plus 10 also, beta. No doubt about it. No doubt about it. Are you getting it? Okay. Now what he said was that in a hydrogen atom kind of thing, there is a nucleus which contains 1 proton and 1 electron is there. Now this single electron can move, and he said that this single electron is not stationary. This electron is actually moving. And from his teacher Rutherford, he found that this electron is not only moving, but it is also being balanced by what? Centripetal and centrifugal force. Yes or no? Centripetal and centrifugal force. Are you getting it? Which was said by whom? Rutherford already. Though Maxwell tried to counter him that, if the electron moves, it is a charged body, it will lose the kinetic energy. But he said that, please listen to my assumptions. I've got something to say, very important. So this first one, second one, and he said that not only, there is a single orbit, like there are many such orbits. There are many such orbits. Are you getting it? And these orbits are actually called fixed energy orbit, or stationary energy orbit. What do you mean by that? Stationary energy orbit, it means that if an electron is revolving in an orbit, it will keep revolving in this orbit with a fixed energy or stationary energy. It will not lose the energy, it will not gain the energy. Very good. But if it does gain the energy, in that case it can move up. If it lose energy, it will come down as well. But if it is not losing energy, it is not gaining energy, it will keep on revolving in any of the fixed energy orbit or stationary energy orbit. These were his assumptions. He also said that when an electron jumps or comes down or goes up, delta E will be equal to what? E2 minus E1. Are you getting that? Also, he said that these orbits, which can be infinite in number, only those orbits are possible. For all these orbits, one requirement has to be fulfilled. What is that? That angular momentum MVR should be integral multiple of h upon 2 pi. It should be integral multiple of h upon 2 pi, where n will be a positive number, natural number, okay, or whole number, 1, 2, 3, 4, and so on. That means n cannot be fraction. It cannot be 1.2. It cannot be like say 3.5 kind of thing. No, it has to be an positive integer. Yes or no? It can have as many orbits as it wants, okay? But only those orbits are possible for which angular momentum is quantized. Yes or no? Chalo, aa jao. Can I ask you a question basically now? The question says that which of the following is possible for hydrogen atom? I'm saying that first one, is MVR is equal to 5h upon 2 pi. Second, I am giving you MVR is equal to 3.5 h upon pi. Third, I am giving you MVR is equal to h upon pi. Come on. Which of the following is possible? Where h is the Planck's constant, है ना? Where h is the Planck's constant. Come on. Okay. Very good. Very good. See, I told you that MVR should be integral multiple of h upon 2 pi. So don't give your answer till you find h upon 2 pi. If h upon 2 pi is not given, convert that expression into h upon 2 pi. Don't answer this before that. Okay. So this will be, this is correct because it is integral multiple h upon 2 pi. 5 is what? An integer. It's a number, natural number. Over here, this is not h upon pi. So I'll make it h upon 2 pi by multiply and divide by 2. So when I do it, it becomes 7h upon 2 pi. So this is what? An integral multiple of h upon 2 pi. Yes. So 7 is a integer. Moreover, this is nothing but 2h upon 2 pi. Don't answer any question in this format if you are having h upon pi kind of thing. Answer only when you are able to make h upon 2 pi. Yes or no? So you see that this is also an integral multiple of h upon 2 pi. So all of them are possible. All of them are possible. Yes or no? Okay. So let's move now. Let's move now. And according to Neil Bohr, Bohr did some calculation and tried to find out the radius of hydrogen atom as such. So he said that R is given as 0.529 into n square by z angstrom. Are you getting it? From here, boys, can I say that R is proportional to n square by z? Can I say that R is proportional to n square by z? And I'm saying if z is equal to 1, in that case R is proportional to n square. Yes or no? It's proportional to n square. So both the expressions are important. Both the expressions are important. If you're talking about the same species, then this is equally important. So can we do some questions now? Can we do? So question is saying that find ratio of R1 is to R2 is to R3 is to R4 for hydrogen atom. For hydrogen atom. Come on. Now for same atom, Z is same. Yes. So this R1 is to R2 is to R3 is to R4. I told you it's proportional to what? N square. So can I say the ratio will be like say 1 square is to 2 square is to 3 square is to 4 square. Yes or no? Where R1, R2, R3 are orbit number 1, 2, 3, 4. Sure about it? So this will be like say 1 is to 4 is to 9 is to 6. Yes or no? Can we see that? 16, sorry. This will be 16. Okay? Okay. Now if I ask you, remember one thing, few more things before I leave. Like say this is nucleus, so this is the orbit number 1, orbit number 2, orbit number 3, orbit number 4, and likewise orbit number infinity. And single electron can live anywhere depending on the amount of energy given to that. Yes or no? Sometimes people ask me, sir, only one electron is there, so only one orbit should be there. No. Orbits can be any. These are all energy levels. So electron can live anywhere depending on the energy given to the electron. Yes or no? This is called orbit number 1, 2, 3, 4, and so on, and infinity. And alphabetically they are called like say K, L, M, N, O, and so on. Are you getting that? Also remember the orbit number 1 is also called ground state. It's called ground state. Orbit number 2 is called first excited state. It's called first excited state. Third is called second excited state. Are you getting that? Are you getting that? Also, remember that energy required to remove electron from the ground state to orbit number infinity is called ionization energy. Is called ionization energy. Remember that is called ionization energy. And energy required to remove electron from any other orbit to infinity is called separation energy. Is called separation energy. This from orbit number 2 is called first separation energy. This will be called second separation energy, and so on. Are you getting it? The difference between separation energy and ionization energy is what? In ionization energy, electron will be removed from orbit number 1, while in separation from other orbits, higher orbits, but not 1. Okay? And one more thing, understand that also. There is something called excitation. First excitation energy. First excitation energy will involve which orbit? Will involve which orbits? Come on. N1 and this is say N2. First excitation energy. That means energy required to excite electron from orbit number 1, ground state. First excitation energy. Second excitation energy. Third one, like that. Okay. So 1 to 2. Second excitation energy will be from 1 to 3. You have to jump from orbit number 1 to anywhere but not infinity. Yeah, excitation is anything except infinity. Correct. But from orbit number 1. But from orbit number 1, you have to jump from orbit number 1. Is that clear? Is that clear? Third excitation energy will be from orbit number 1 to orbit number 4, and so on, and so on. Okay. So we'll be finishing of the class here because the new thing will require, like say, more time. So we'll be carrying on in the next class. Till then, you just keep on revising. And thank you so much, boys and girls. Thank you so much. God bless you and have a great day ahead. Keep revising, keep studying, and keep rocking. Bye-bye. Bye-bye.